Oh, we're having a really good time here. It's really good. I forgot to even unmute us. So I've not got a camera working and my sound wasn't on. I'm doing good this morning. Why is the camera not doing anything? Yeah, audio's working now. Right, we've got one camera there. That's the wrong camera, but it's a camera. All right, let's just see if we can get the other one doing. No, it turned on and then turned itself off again. I don't know what's going on there. We'll work with the other camera then. You'll just have to suffer me being in a slightly different way. Oh dear, that isn't actually, although it's there, it's not actually appearing. What? Oh. Well. Okay, what we're going to do is I'm going to go and set it back to that camera. And I'll just try unplugging it and plugging it back in again. Unplug. Plug in. How are you feeling? Are you going to work this time? No. All right. Well, there will be a brief break. Brief break. A brief break. Quite quiet as well. Yeah. Well, let's see. That's on quite sensitive actually. Yeah. All right. Well, let's do a little bit of messing around. I will be back in a second. I'm just going to go and try to fix these little bits. All right. Back in a mo. Hello again. What do we got? We got a camera? Have we got a camera? No, we've not. No, we haven't got a camera. I'm very confused. I don't know why it wasn't. It was definitely working previously. I think we may just have to suffer with a different camera, and I'll just quickly try and set that up to be. Oh, that's just not going to work, is it? Well, maybe we'll do something without a camera. Maybe that's what we'll do. Maybe we'll just suffer without the camera. Oh, I know what will have happened. I know what will have happened here. Oh, stupid person. Right, do that. Hello. Oh no, that's not quite right. There is definitely a problem with that, isn't there? Yeah, we probably don't want to. Can I do it? Oh, there we go. There we go. That's better. The technical fun we have here. I mean, you just don't get quality like this on other channels, do you? And thank gosh. Right, let's put that there. How are we looking? Yeah, a little bit off, but we'll cope, I think. Which way do I go? No, I don't want to go that way. I want to go this way. I can't go that way very much. Let's just move me over a little bit. There we go. You kind of got me in view. It's not that anybody really cares, but here we go. Did I upgrade the OS? No, I intentionally didn't even upgrade OBS to try and get this working. So, right, well, I will have a fiddle with that later. I'm sure it'll be fun. It's really good having a dedicated camera that's intended for this. And yeah, it doesn't end up working. Right, so is the mic okay? I've moved it a little bit closer. Hopefully it'll be a bit better for you. Yeah, I don't tend to talk with the mic very close because I can't see parts of the screen. It's a bit of a pain. Right, so we're already 10 minutes in and I haven't even said anything because we've been technical issuing. This is why I should be prepared beforehand, but I was doing other things and getting myself ready in other ways, like trying to get myself sorted out. So, hello and welcome to Live Coding with Gerph. Today we are starting on a new project. We're going to do an implementation of the star GOS command, which is it's not the command line interpreter, it's just the command line reader, essentially an environment that you have, a supervisor that we have on startup. So that's all we're going to be doing. It's not especially large, but it's going to be fiddly because it's a bunch of environment things, and yeah, it's going to be a bit awkward. So let's start out by jumping to, here's the actual status and things we're doing. What we're working on is essentially it's the utility module, because that's the only thing that actually does this. So utility module it's intended that we finish this in phase 1. Fair enough. And here's all the things that it does. So we should have a command line prompt. We should report errors. We should trap errors, exits. We should trap errors trapped as well. We don't end up escaping, and we trap the aborts as well. We should implement star GOS, and we probably need to manage star memory and star reset according to, this is automatically generated, this page, aside from the functionality section. So it thinks I need to implement those. It being a program that I wrote that analysed the modules in the system. I got a little thing that goes and interprets the module header and some of the code in it to work out what is actually being done. So that is what we're going to be doing, and it's going to be a bit fiddly, as I say, but let us first start out with a project. New project. So first thing I want to do is to pull up a new, so this is the I didn't do a release on that. I did do a release on that, yeah. So this is the old project we had. I've got a new release on this. Oh, it didn't, it was drafted. Yeah, let's make that a real release from last time. What was that? Sorry, what did it say it did? Generate release notes? No, thank you very much. That's not very helpful, is it? Ensure tiling fallback is enabled. Ah, that's right. Yes, because tiling wasn't working. Over the original release, the following what I've done. Let's put that at the end of the line there. Oh, we don't need to say it's trivial to enable because it just is. There we are. Okay, so that's now released, which is good. So that finishes off the last block of work we did. All right, so let's create a new project. So new repository, RISC-GOS. We'll call it GOS because utility module in RISC-GOS Select meant just star GOS. In RISC-GOS 5, it means star GOS and a whole bunch of other things that we don't care about because they're separated into separate components. So let's go do this. This is a star GOS implementation for RISC-GOS in C. Create new repo. Right, and let us go do that. So down here, git clone, sorry. This. Copy, paste. You appear to have cloned an empty repository. Yep, that's exactly right. Because now we're going to go and populate it. So RISC-GOS. The way we're going to implement it is by starting out with just a simple command line tool that does the things that we want it to do as little stubs, and then we'll turn it into a module. And by doing that, we'll be able to basically get the structure right, and then we'll be able to expand it out to the actually complicated bits. And I'll try and explain why the bits are complicated as we go, because it's going to be a bit of a, yeah, it's going to be a bit fun. But let us give it a whirl. I'm feeling I'm very flat here. This is not feeling right, but no matter. We'll cope, and I'll sort out the camera at another time. Okay, so first thing, RISC-GOS project. Create a new project, a command, not draw flattening. Let's call this GOS. Yeah, we'll call it GOS. Why not? And we'll create the skeleton to go with it. Bum, bum, bum. Oh, yeah, Docker's waking up. There we are. Right, so we've got some files now. RISC-GOS ammo. Let's build that and just show that it works. Ooh, what I should probably do is show what GOS actually is. So let's run star GOS. There we go. Right. It's very, very exciting is the supervisor. Here we are. That is the supervisor, and it lets you run commands. That is pretty much it. If there is an error, hello, it reports the error to you, but keeps in the loop. If you run something, so if I run af32.gos, the new command that we just created, it goes and does that, runs it, and then returns back to the prompt. And that sets up a program environment for it, and then goes and tears the program environment down. So hi to other people. Yes, Spanners wants to speak to my supervisor. There he is. So that's what it does for this. Okay. Oh, my nose is all itchy. So I think I may have a little bit of a reaction to the springtime that we're in at the minute. A little bit of hay fevery stuff. It's all right, Andrew. I'm sure the furniture was in need of moving anyway. Right, so yeah, all I've been doing is just describing what we're implementing here and what GOS is. It doesn't do anything like that, anything other than that. In RISC-GOS Pyromaniac, it also implements star quit to exit the system. Andrew says that the boss says the furniture needed to move. That's absolutely reasonable, yes. There's nothing you can do about that. You have to move it when it's needed. In fact, you like to move it. Nah, it wasn't that funny, I know. I can amuse myself, can't I? Sorry, I'm far too amused at myself. Let's go. Okay, so that's what GOS is. We've created some C files, so let's commit them. No, let's actually add them first, because if you don't add them, nothing happens. Git add C version num and makefile. There we go. Commit. Add the skeleton application we will use initially. We're building star GOS first as a simple regular application, and then we will start to make it into a module. Right, okay. Status. Right, so we still have some empty files there. So those ones, it's not empty files, some built files. So git RISC-GOS project, create git management, and that will then hide those files. So now I've got git ignore and git attributes. Ignore and git attributes. Andrew says he laughed, groaned, and laughed. And Alan was noticing that I was singing. Yeah, I don't think I'm quite singing. Add something or other. What am I adding? Adding source control files. So why do I do these things? These things as in adding these attributes files. That'll just make sure that when we push things, they end up being noted as being C code, and we note them as being ignored when there's generated files as well. So all a bit easier. And the reason that we do it all through RISC-GOS project is because then we don't have to write any code. We can just, like, it takes it from a skeleton and a template rather, and builds it. If anybody wants the source to this, I will make it available at some point. It is available, however, in the RISC-GOS build environment. So if you want to run that, go for it. You've got it. So you can always have a play with it in there. So this is the CI system. So if I look at the CI system, we've got a GitHub file and a row build file. So we'll go and commit those as well. Add CI files. Allow the project to build automatically. We'll push that. So now that we've pushed that, if we come over to here, which is the source repository, in case anybody wants to follow along as we're doing things, we'll put that here as well so you can see where we are. If I reload it now, reload, not cancel. We've now got this here, and if we have a look, it's done the little dot to say I'm working on it. There we go. That was the build. It took 10 seconds to go and build it, and it just went and sent everything to there, built it, and then ran the command to check that it was working. There's a little bit of a problem here because we don't have a locale set. That's to be fixed shortly. I just haven't got around to it yet. But yeah, that doesn't actually make any difference because we've not actually got any command help at the moment. So we've now got a skeleton. We do want one other thing to be done. So we want Riscos project. Actually, there's two things we should do here. Create PR. So create PR will create the issues management and pull request management. So if we look in here, we'll see that it's created some templates for these. And I haven't really talked about these in the past, but if we just have a look at one of these, so have a look at this, you'll see that it's basically a little template that says, tells you what you need to do to go and create a PR, and then tells you how to describe what you did for testing. This is generally a good thing for people to do, so you should always try and describe in reasonable detail what you've done and what you've tested. And then if somebody is reviewing it, they can then see what you intended to do, and they can check that you did it, and they can see whether the testing was sufficient or not. Because if it wasn't sufficient, then you're probably going to need to do something else. If it didn't actually test the thing you were trying to test, you need to do that. If it tested too much, then you might want to split it off. So there's things there, but that's all quite useful to do that. Right, and then the other bit is the issue templates. So have a look in here. I mean, I'm not going to go into these too much, but you can see that there's a feature request type issue. It says, is it related to a problem? Describe it. Describe what you'd like it to do instead. And then if you've got any additional context, like screenshots or mock-ups, or anything else that could help, that would be that you put that in there. And the same sort of thing goes for a bug report. So in a bug report, we've got some things here saying what's wrong, what environment you're in, because it matters if you're on certain systems. I mean, it might not, but it's useful to know. And then what you expected, and if you can do it, some reproduction steps, all of which is to guide the person who's submitting a fault to try and give us the useful information to try and fix things. And I've tried to do that everywhere. Additionally, we've also got this code owners file that describes who to assign things to, which at the moment is just me. And there's also, if I have a look in GitHub here, there's also another one, which is a workflow that's in here. So if I have a look in the workflows, there's a workflow issues here. And this assigns automatically to me. So if somebody doesn't go through the pattern that was there, it'll still be assigned to me anyway. So that's all we're trying to do with this. So again, long description of how that works, but it's all very useful to try and get us helpful feedback. Code owners, there we go. And I'm only adding the GitHub part of it. So if you have a look here, we will see that we've added the GitHub part, but I'm leaving the GitLab stuff behind because I'm not actually using GitLab for this, so it doesn't matter. But essentially the same configuration is present in GitLab as well. So that makes things relatively easy. So we'll add in, so this is add issue and PR templates. Issue and PR templates make contributions more helpful by being guided. There we go, and we'll push that as well. So one other thing that we can do on here is if we go back to the top of the repository, we can add a README, but also we can mark this with some topics. So we can mark with Riscos, because it's doing Riscos. We can also put CI in there because we've got CI, and it gives us some examples of that. We don't want deployments or packages. We can actually give it a URL. Let's give it this URL here, because that's what we're going to be implementing. There, like that. There we go, and they pop up over here. So, shall we write a little README quickly? Yeah, let's rattle off a README, but we'll do that in a proper editor. So let's edit this stuff. Here we are. It replaced it. Good. That's handy. So let's create a README file. New file. README MD. Right. Star GOS implementation for RISC-GOS. Yes. Module. Let's have some tense here. Will contain a module which provides the Star GOS implementation for RISC-GOS in C. Previous implementation was built into the kernel of RISC-GOS Classic and provided and written in assembly. I'm getting it right, Dave. I will get it right. Assembly language. There we go. We'll do it. Leave it at that for now. Status git commit readme.md. Oh, I need to add it first, don't I? Oh, there's something else missing as well. We're on to license. Let's grab a license. / RISC-GOS WIMP templates. Well, any of them will do, won't it? License to there. Let's have a look at it, check that it's right. Commit license. Yep, that's good. Okay, cool. Let me add license. Where's that? Simple readme and license. There we go. Right. Yeah, half an hour in and we've still not written anything useful. That's not true. We've set things up. It's possible I may put the license stuff into RISC-GOS project at some point because I think that'll be useful, and probably we'll do some other bits in there. But for now, this is all working okay. At least I think it's working okay. Alrighty, let's have a see what we can do. Let's go and refresh this window because it hasn't actually updated. I have far too many windows open, so it's actually or files open, so it's not updating automatically. It's a frustrating thing. Okay. Excuse me. Let's write some code. So, Star GOS. What does it do? So, I'm going to describe what it does, and as I'm going to describe it, we're going to put some comments in here to say what the GOS implementation should be doing. So, first thing we do is we get entered and we have stack setup, which we won't worry about here. Stack setup is in assembly before we reach here. Okay, so that's a stack assembly stack setup. How much stack should we have? We should have, I don't know, a couple of kilobytes. Because we need something. We need, what's it called? Command line input, which is a few K. Yeah, let's have some tidying on this, shall we? I'm sure there'll be other things we'll need here. So we need to set up environment for the Star GOS system so that crashes, exits, errors, and errors are handled. And okay. we need upcall handler set, because otherwise switching environments, switching contexts will break. What else? I think those are the main things that we need. Actually, also here we need global workspace. We need some global workspace setup. Because of how star GOS works, we're not going to be able to use global variables. We're going to have to use a global pointer to say what our workspace is. So if we're going to do that, let's actually create one. So type def struct global structure. And what we're going to need in that, we're going to, at the very least, we're going to need some space for a command line. Just our CLI. What else are we going to need? We're probably going to need some workspace for storing the environment into stored parent environment, so we can return back to something. Now, returning back from GOS isn't actually possible. So the supervisor, when you do star quit, won't actually return to anything because there is nothing to return to. The system is only going to have a single star GOS environment. In RISC-GOS Classic, this is not true in RISC-GOS Pyromaniac completely, nearly but not quite true, and I think we should aim for having this being a system that can be entered multiple times, so that strictly you can do star GOS in multiple task windows and it be safe, because it's not quite safe, and other parts of the system be able to function in the same way. So that's what I'd like to do. I'd also like this to be something that you can basically copy and make into another environment, which we will need to do for certain parts of the system. I'm just remembering actually that did we implement star debug when we were doing the debugger module? Because that's very similar in what it does. So let's just finish this and then we'll have a quick look at that. So global workspace T. So there we are, and we'll basically have some global workspace T star. We'll call it global. Global's a good name, yeah. And we're going to want that to point to something. Actually, what we'll do is have main be the thing that starts stuff up. So here's global, which is being set up here, and initially it'll just be some space, and then we'll go and call the thing that is GOS with global. There we go. And then all of this will move into GOS. Global underscore T star global. Should I call it global or should I call it WS? I was about to call it WS then, which makes me think that maybe I should call it WS. No, I'll call it global. I've decided on that. Right. So we need some global workspace set up. That's what we've got there. We need to set up environment handlers, upcall handlers. We output the CLI $prompt string or star if none was set. Okay. We then read a line of input from the user. Then we start going into the actual processing. We set up another environment here that will report errors, crashes, exits and errors, and then return to the input loop. So let's make this an input loop while still running. Then we go and we invoke oscilly on the line input. That's it. If there is an error, we call os generate error. Now, why should we call os generate error here? In fact, actually, if we just call oscilly without a, actually, we probably need, yeah, we'll do it that way. If we call just generate error or use os CLI directly without X. And that'll give us the same handling. So if there's an error either through os generate error or coming through the error handler, they'll both go to the same place, and therefore we'll get the same type of error of output from it, which will be a lot easier for us to read. And then after that, what do? We then go and return back to the beginning of the loop. Yeah, we go back to the beginning of the loop. That hasn't given us any way to exit, so check whether the input string was star any number of times space any number of times quit in any case. And if so, we exit the loop. Okay, is that it? Almost, because we never restored the error handlers here. So we need to restore the error handlers to the outer GOS system. So there's two sets of error handlers. There's the error handlers up here that are around the whole thing, and the exit handlers and crash handlers. And then there's the ones inside here that handle the invocation of the command line. Why do they matter? Because if, for example, something was doing interrupt work and caused a crash, we want to trap it outside here as well in a different way to how we handle it here inside the command line loop. Why do we handle it differently? Because otherwise we would be exiting out to a parent system, or we would be reporting something that's to blaming the CLI command. And we may want to do some other redirections and other handling in here. So there's a number of things that we can try and do here that can vary the behavior. So there's basically so there's another part of this is if whilst running oscilly itself we have a problem, like the oscilly command crashes, maybe, I don't know, one of the module implementations of the command that's handling it breaks, we want to be able to handle that. We also want to be able to handle os readline breaking up here and read varval breaking up here. So we want to be able to handle all those cases, and they're all slightly different. So that's what we're going to be doing. That's, I think, the basic skeleton of how we're going to do this. So we'll just put some things in here so this would work. Stud bool, sorry. Bool still running is true, and then we'll actually just set it to outer. Yeah, there. We'll just set it to false here. Stop us looping forever whilst it's stubbed. Okay, so, oh, and that should be an ampersand global there to make that do it. Let's see if we can build that, shall we? We'll build it inside the editor as well and see if it works. Oh no, that didn't work. Oh dear, what did we do wrong here? So let's have a look. Oh, because it's not a global T, it's a global WUS T. Yep, that built. Okay, and if we want to run it, so pyrodev common aif32.gos. Yep, and it exited. Thank you very much. So that's quite cool. What I said a moment ago is we should have a quick look at the debugger code. Is debugger up here? It's not. And I suspect it's not up here because it's actually in my... I separate my projects, things that I've done completely from myself, or sourced from me, to things that have been sourced externally. So /external, and I think it's under port... There we go, ports debugger C. There we go. Let's have a C in here. So we have a look in CMHG. Do we have a star debug implemented? Lots of things here. Dum dum dum. Star debug goes to command debug. Interesting. Okay, do we actually have that? Where would it be? In module maybe? Veneer. Dum dum dum. Let's have a look. Command debug. Ooh, look at this. Ooh, look at this. We have some interesting bits here, don't we? This is very similar to what we want, isn't it? That's quite cute. I mean, it's not very clever or anything, but it's basically the loop we want. Although probably not going to actually want to use it this way because we want the extra environment handlers, which this doesn't do. Maybe this should be doing environment. I don't think it should be doing. I don't know. I don't know if debug installs environment handlers, but in any case, look, this looks similar. We can pinch bits of this, I think. At the very least, we've got these write functions here that we can go and grab, which will make things a little easier. Oh, go away. Yes, we're not doing breaks. Give me a break in an hour's time, please. Thank you very much. I've got a little bit missing there. Doesn't matter. We're not going to worry about this because the debug is only triggered for either breakpoints or whatever. So that's not a big deal. Okay. And then 64-bit, we're not implementing it. Fine. We'll work something out for 64-bit. If we're continuing, yeah, that doesn't look. Yeah, we're probably going to pinch the implementations, but not the actual code. So let's have a see, shall we? Something went wrong in readlining. We're not going to do anything. I probably want to get back an error there, actually, don't I? And try and report it and then exit, because we can't do anything if we can't read lines from the user. Okay, and we can't use statics. We can only put things on the stack. All right, let's just grab a bit of. Do I want to grab the bit of this, or do I want to just grab the implementation and write it again? Because it's not a lot that's actually useful here in the actual code. No, probably not much that's useful, but there is going to be stuff that's useful in OS that we can pinch. So here's the readline implementation. We can pinch that because that's also got the 64-bit stuff in it. And that's it, actually, all we've got in here. Yeah, all right then. Pinch that entire file. Ooh, pinch it, don't delete it. And we'll put it in here. New file, os.c. Yeah. We're not going to need os confirm, but we are going to need os-lee. And we'll just implement this very simply at the moment as a const char star CLI. So why am I not doing this through kernel os-lee? Because kernel os-lee also uses some static memory. Therefore, I can't use that. It uses global space, so I don't want to do that. Swix doesn't, and so we're safe. So here we go. We don't want to call os confirm. We want to call os-lee. and then we don't want to do that. We just want to do CLI, and we're doing this as input register. There we are. So we've now got OSLI provided. We want to provide a header for this. So let's go and create a header file. New folder H. There. And what do we want to do? We want to basically copy all of this, I suppose. Actually, I can pinch it from the other one. Be easier, won't it? So we've got a header in here. It's got that. Yeah, most of that is going to be the same. We'll just create a new file. OS. Oh, I called the other one os.c. That's stupid of me. Shouldn't have been os.c. It's just os. I'm working too much with other systems, aren't I? There we go. Just going to rename that. And then we can we'll be safe. July 2025 that was written originally. Yeah. Simon's birthday, my brother's birthday. OSLI. Oh, I can just copy the prototype, can't I? It'll be a lot easier to do that. Let's copy the prototype from there. Oh, also I said I wanted to return an error if there was an error, didn't I? So let's actually do this with an error here. So pointer to an error or null if none. Kernel. Oops. Dear me, I can't type. There we are. Right, let's make it do that, and we'll just copy that into the other code as well. So we've actually got it in here. So, get rid of that. If there is an error, we want to return the error. Oh, escape is returned there. Yeah, so if there's an escape, if error, return error. If there isn't an error, actually that should be returning null, shouldn't it? So it's failing. If there's an error, return the error. If it's escape, oh, that's frustrating, isn't it? How are we going to do that then? Oh, we'll do it as a error block. Escape. There we go. Riscos UK has turned up and say they were busy listing half a garage full of RISC PCs. Okay. Trying to get rid of them, I guess. Anybody wanting a RISC PC? Talk to Riscos UK. I'm sure he'll be able to set you up. Always a useful thing to be able to do that. All right, so we got those calls. So we just need to put a. Oh, except of course we haven't got. We're not in CMHG at the moment, so we're not going to have an error escape. Right. What we'll do is we'll very quickly go if def in simple app. We'll call it define. No, not define. Static status static escape bracket 17, because everybody remembers the code for escape. Well, if you used a BBC you would do, I suppose. Error code 17 has always been escape on the Beeb, so there we go. Return that, and then we can set simple app as one of our defines. There we go. Oh, whilst we're here, we can also add this. Come on, o.os. So we build that. All right. Go back to here, and we probably need to include the os header. Include os.h. Right. I couldn't spell weather apparently. I also still can't spell it because I put the H in the wrong place. Read a line of input from the user. Right, we can do that. So CLI here. Why don't we get the assembly code to go and set up the CLI? Global to CLI equals malloc 1024. define CLI size 1024. So it isn't 1024, but we can just say that for now. Fix me, read the CLI size of this OS, because the CLI size could change on different operating systems. So there we go, we've got a CLI size. Oh, in fact, if that's the case, we also need to communicate what the CLI size is, don't we? So there we go, we can pass that on. So global, oh, dot, isn't it, in here? Oh, yours is itchy. CLI size equals CLI size. Global. There we go. Now we can call os read line here. So let's do that. Os read line equals os read line. I've forgotten the parameters. What we got? A line and the length. Fair enough. That's pretty easy. So the line is going to be global to CLI, and the length is going to be global to CLI len size. Sorry. Now, if I remember rightly, os read line normally returns things with a return on the end of it, but did we clean this up so it didn't? Yes, we did. We returned it so it's a 0 terminated string here. That makes things easier for us. So let us do that here, shall we? Os read line. If we got an error, we will go and report an error. So if there's an error, we call os generate error or use CLI direct. So what we're going to do here is we're just going to print it out for now. Error okay. Error is the string, which was to mess and to num. And of course, at that point, we are now complete and we want to actually exit. Ooh, this is where we think, oh, the GOS command should probably return an error if it failed. And actually, this return should have another bit here, which is restore error handlers for the parent system. And actually, what we can do is we can do this up here. If error is set externally, if error is set, raise it, which will actually return it. So that the assembly can raise the error. And then out here, free the global workspace. Oh, we don't need to free it because it's a static, isn't it? A local, sorry. And then raise any errors. So here, if equals that, if raise error to parent environment by calling os generate error on this. Okay, and of course, for our example code here, we can just do exit failure to indicate we failed. Right, so that'll handle the case where read line has failed, which might be an escape. If it's an escape, though, we want to actually. Oh, that's interesting. So if you pressed escape, we don't want to exit. So if to num is escape. If it was just an escape, we keep going around the loop. Continue. Other errors are fatal. Okay, that makes sense, I think. The question here is whether we would actually get the escape handler called here, which we would, but we wouldn't do anything about it because we can just return. So there we go. Continue with a semicolon on the end. At this point we can actually printf red line global to CLI. Check if the input string was start any number of times, space any number of times, quit in any case. So we can do that. We'll just do a quick check for things. So const char star CLI, yeah, CLI, that's good, isn't it? Equals global to CLI. While space or star. So that's going to skip us all the way up to the next bit, and then we can do if, oh no, that's not right, sorry, what I meant was CLI++, skip the letter, missing one keys. Yeah, skip that. If CLI bracket naught equals C or 32 lowercase. Put some brackets around this to make it clearer. Brackets around that as well. Nice and clear what we're trying to do here. C. Oops, no. It's not C. I want Q. Let's say yourself quit. 2, 3. Quit. And if the next character is 0, if it's a null character, star quit used, return to parent. Right. Explicitly set the error to be null because we don't want any error returning. There shouldn't be one, but we're going to explicitly say that. And then we can go break and leave this routine. And then here we would set up the environment, invoke the command, and then go around the loop again. So at which point we can actually remove this still running. I think still running probably will end up being true all the time. Can we see if it works? See if we've broken anything, if we've written valid code even. We have not. Line 15 in OS. That's probably this, yeah. Implicit cast of non-zero. Is that because I need to do brace like that? Is that what it's meant to be? Nah, I don't like that. Right, in which case we'll just assign it to be this. I just don't care really at this point. I just want to get it to work. I'm feeling dumb, so I mean, you shouldn't be surprised that I'm feeling dumb because that is just how I am. Ampersand escape. There we go. Oops, no, that should be there. Oh, please do tell me if I'm making stupid mistakes as well. I don't mind. Line 79. What we got in there? No side effect. Oh, it's a void still. Let me just change it to be a kernel OS error. let's give this a function. So command GOS, run the star GOS implementation, supplied only with workspace. Global points to our global workspace, and we return pointer to pointer to an error. Post to the caller or null if just exiting. All right. So that's what this function should be doing. Let's see whether we can actually get it to run. Oh, it's built. It's built. Does it work? Oh, we're not actually printing out the CLI prompt, are we? Hello. Red line, hello. All right. Quit. Red line, quit used, return to parents. Thank you. All right, so there's no star in there. I need to put the star in there. That's not a problem. Right, so start quit. Yep, it likes that. That's good. And what else can we do? Oh, I want to see what happened if we did Control C. Return. Interactive news. Oh. So that's the escape handler for the C system handling it. Right, let's make sure we actually print out this star at the beginning, just so we can actually see when we get to this. Just it will make it easier for us to see what's going on. What else? We'll do that. And I probably need to just, in order to make this a little bit more like we're going to be seeing in the real world, let's go and do signal sig int to be sig ign to ignore it. I believe is that how you do it, or is it sig int like that? Sig int like that, isn't it? So we need to include signal to make that work. Oh, let's stick my name in. Why not? Gerph. Oh, come on, typey. Right, are we still right? Are we still working? Still building. Good. Okay. So star help won't do anything, but we can actually press Control C. Got as an escape, and it recognized it as an escape and didn't do anything. Didn't exit back to the parent. So can we make it exit back to the parent automatically, do you think? See if we can do that. If we force os readline to return a different error, which we can do by just making this return 18 instead of 17. So were escape to return 18 instead, we can just check what happens with that. So there we go, and we recognize that we should be returning back to the parent. Okay, so that's good. That's going to do the right thing. Okay, let's actually make it do something in this environment. So this is the C environment, the regular one. So we're not setting up the environment. We can at least call system, and this will actually do the right kind of thing. So we can call system on the CLI. So we'll end up with a very similar environment. Now, one thing we get here is we've actually got a do we get an error code out? I can't remember. I'm going to just do it this way just to see what we can end up doing this. Build that. Apparently Riscos UK hates SCSI cards. Each to their own. That's global CLI. There we go. That should do that. Sorry, build it. And then run. Help. Ooh, look at that. Star dots. Quit. Okay, so we have a very, very simple environment there. Now the problem with this is that we're actually running this in the C environment, so we're not actually running with environment set up, and we're using application space, which is not what we want to do for star GOS. So we're going to need to replace that a little bit. So let's have a quick look at this. Let's go and commit some code. C and H. What we done? We've done quite a few things, haven't we? That didn't line up properly. Why doesn't that line up properly? It's the tabs, isn't it? I don't care. It's fine. I'm not worried about it. Commit minus A. Right. Fill out the main input loop and report errors in vaguely same way. Oh, report errors. Simple system, not environment, that looks kind of like it would be in the real OS, but in application space. Okay, push that so that people can see it. If you're interested and you've joined late, you'll find it here. There we are. And again, we should have this running. Oh, it failed. It failed on the CI. Why did we fail? Oh, so in CI, the system is configured to just reset the machine if you try and ever do input, which makes sense because, well, you don't want to do input here. If it was to ever hang there, it would be wasting CPU time, basically, just doing nothing. So instead, it just resets the machine. How can we actually test this? We can't, can we? I'm just going to have to remove that from the build command because we can't run it as it is a CLI input. We cannot run this command here as requires input to work. So we're going to need a different way of testing this. Fortunately, we do have some mechanisms for doing that. It's just a little bit more difficult. I will work on the test stuff later. It's probably going to take us 3 or 4 sessions to get this to the point where it's working and has some tests. It's going to be a little bit fiddly, but I think we're going to get somewhere with it. Well, I hope we do anyway. There might be some nasties in it, I suspect, but I think we could be good. Yeah, I think we could be good with it. Okay, so let's just disable running the command as it doesn't work. And in the future, we will be more clever. That's all we'll say. All right. Okay. And then we can push that as well. So it's going to sort the problem out. Okay. Before we get on to doing more complicated things, I just want people to have a quick think about how we're doing things here. So as you can see here, we've got this code set up in a structured way. My plan is that I'll do some more next week and some more the week after. But if I look at the calendar, which you can't see here, but I've got a calendar. Yeah, next week is Easter Sunday, isn't it? So Easter Sunday, I'm expecting I'll come along to this, but there might not be many people around. If nobody's going to be around, then I may skip the week. because it just won't be worthwhile. I don't mind. We've got 12 people here at the moment, it looks like. That's not too bad. But I'm hoping that we'll be able to get like some people in. However, over that following week, I'm also planning on doing some. I've got a little bit of time off. I've got Riscos UK will be here. That's good. So this will be somebody. Okay. Sorry, where was I going? Yes, over that week, not next week, the week after. I'm on holiday. So I'm on holiday, but I am on holiday doing Riscos things. So what I'm planning on doing is both a little bit of work in general on things, but I'm also planning on doing some short form videos on how to do some small tasks, how to set up things with the build system and how to run stuff and how to sort of do some general easy to use things, hopefully with the idea of them being 5 to 10 minutes max. This is a little thing to do. So that's what a lot of my time will be taken up in. So if you've got anything particular, it's just a very short, how do you do this? For example, I've got this bit of code here that's just a small thing. How do you do this? That'd be cool. The things I'm sort of thinking of doing at the moment is how do you create a GitHub project for Riscos? How do you start basically the basics of Riscos project, how you can drive that and what it does, how you can create a module, how you add a star command to a module, how you add system call to a module, swy call, how you add events to a module or vectors. Probably vectors is probably more useful. How you add a simple service announcement to a module. So just describing those and then demonstrating as I'm coding it the same way. Just as a very short, this is how you do it, now it's done. That's what I'm planning on doing. I hope that's going to be interesting to people, but I'd like to get some people's feedback. If you think it's useful, that's cool. If you don't think it's useful, then that's fine. I'll probably still do it anyway because I think it's going to be something that we need to show off. I'm also going to show off some other bits about the build environment and how it works, just to try and give people a bit more intro into how to do these things. Also, there'll be some. I'm hoping I'll get through like 5 or 10 of these videos. I don't know if I'll do more, but that's what I'd like. I'd like 5 to 10 videos. And they're not going to be highly planned videos. They're going to be just, this is what I want to do it, recorded, ready to go. And I'll also be showing a little bit about how you do CI management as well. So I've sort of obviously shown a bunch of this in the work that I'm doing here, but being able to show once you've built it, it comes out here, and this is how you can modify it to do something slightly different and do some testing and things. It's not going to really be difficult, I don't think, but I think I'm hoping it'll be useful to people. And even if you don't want to watch them, they'll be there for other people outside the community to do. Because one of the things about the Riscos build environment is that you don't need Riscos. You don't need a physical hardware. You can do it on any Mac, Linux, Windows machine, and therefore that makes it a lot easier, more accessible to people. Or you could throw it up in the cloud if you wanted, but you really want to run things in the cloud on a separate machine. So that's the sort of thoughts with this. There's very little module on creating modules in C. I ran into all sorts of problems when you created the first module last year and took months. Right. Well, that's quite interesting because, as you can see, Alan, when I've been writing these, here's a module, done. It's also very interesting when you try doing that and people don't understand it or the oddities about it. So I will talk a bit about that. I mean, yeah. So there's modules, swy calls, modules, commands. I wonder if I can do something for the toolbox as well. I think toolbox is a bit big actually, but I can at least show people how you do skeletons of these things and stuff. Anyway, that's what I'm planning to do. So particularly if creating modules is a thing, I will try and show people that. I might also do my first commits in Git as well. I might do a little bit of showing off for that because I know we've shown that before, but it's not the it's not necessarily the process of working with RISCOS that's a problem. It's the process of RISCOS people working with Git, I suspect, to be the problem, because there's very little that actually people are doing properly, I think, with that at the moment. Anyway, that's where I'm wanting to go with that. I'd like to make it so that we've got some more guidance out there for people. And this is all part of the RISCOS 64 project in general, which is about bringing us to 64-bit through high-level language C specifically, and getting people to the point where they can contribute to things. And there is the necessary tooling, environments, and general information so that they can do so in a useful way and be able to contribute if they wish to. That's what I would like people to be able to do, whether they are existing users or not. So yeah, that's where I'm going. Hope that sounds interesting to people. That is where we're going to go. What I'm going to do right now, though, is I'm going to go and pop off and grab some drink and take my break just a few minutes or a quarter of an hour early, because I'm parched. I think possibly because I've been talking quite quickly, and this is a good point to do so. So Nitrex has also said doesn't understand the use of poll word correctly. Sometimes you have to receive the poll word, or you have to use the copy you stored. Okay. Oh, when you were using filters. Oh, you didn't go in for anything easy, did you? Yeah, using Filter Manager is not simple. And if you want to, part of the issue with using the poll word with filters is you have to interact sensibly with the host application, and so that's not a very, it's not especially nice. It sort of depends on what you're trying to do. So I may not go into Filter Manager yet. It may be something we'll do in the future, but it's definitely more than a 5 to 10 minute subject, and it'll be based upon other work that we're doing. So saying that, you see, I'm thinking Filter Manager, I could actually do that. I could actually have a rudimentary Filter Manager implemented in there. Right. Anyway, all ideas for the future. Right, I'm going to pop off and grab a drink, and then I'll be back in a few minutes, probably about 10 minutes. Drink and stuff. Beric. Okay, that's a good word. Break, and we'll be back. All right. Again, if anybody has any sort of thoughts on things to do with that, yeah, feel free to jot them down here, or post them to the RISCOS coding topic on the RISCOS forum. Actually, very cool. Yeah, let me quickly put a post up on there. Can I do that? RISCOS. I don't think I can. I don't think I have a login on this. Give me a second. What I'll do is I will pull it up here. Right. So my Chrome doesn't have logins to some parts of to some systems, whereas Firefox does, and the idea is to keep the two separate. So that planned short form videos for RISCOS coding. A few years ago now, wasn't it? Oh my gosh, a few years ago, there were a number of RISCOS coding videos that people were creating. These were quite interesting, but they seem to have tailed off. I'm going to make some. I could have been writing this whilst I was talking, couldn't I? That would be make more sense. Well, I'm going to create some videos. Oh dear, videos shortly, which describe how to do a few things in a short 5 to 10 minutes video. Not complex or involved. Just single task to completion. Things I'm thinking of are, what did I say? What did I say? I said creating GitHub project, creating skeleton application, command line tool, creating skeleton module, adding swides to a module, adding vectors to a module, to R, adding service handling to a module. Maybe some other bits as well. So I also said installing the Viscos build environment, a short tour around root, around using the build environment, and using CI with Viscos repositories. So that's a number of things. I've got too many of those in there. I do like that plugin. It's using what do we call it? Language tool to pick things up. It's quite nice. What was it complaining about? Suggestion, punctuation, but go to it. Oh yeah, all right. All right, that's fair enough. But I'd also like people to suggest things. They're small enough. I'll show how things can be done and maybe a little explanation why, how and why. Please, feedback here. There we go. So if anyone's got anything, post it on there. I'll just quickly post it on the chat here. But now I'm going to go and have a short break. Oh, that didn't come out right. Oh, that didn't work at all, did it? 2 messages. That 10-minute break. There we go. All right. Okay, we'll see you in a little bit. Yeah, hopefully we'll have some more progress on bringing out parts of this that are useful. All right, so go to the break titles. There we go, break title. See you in a bit. And we're back. Hello. Hopefully we'll be able to get a bit more done. So what we're doing, we are, excuse me, drink the tea. I'm trying to put together a little bit more of what's needed for the GOS implementation. So we're going to need to do a few things here to get something useful out of it. Oh, excuse me. One of the things we can do here is we can get the this using a red value into the string. So what the best way of doing this is probably going to be, why don't we have a string here? So const. Actually, no. Why don't we actually make this a function? It'd be a lot easier, wouldn't it? So write command prompt. There we go. And if we put it all into one function, we can actually have it entirely isolated. Should be a bit easier. So there we go. Void write command prompt global workspace t star global. And what we want to do is we want to read a variable value. So presumably we've got a variable value reader in, oh, we haven't got it in the debugger C module. I wonder if we've got one in one of the other modules. Because I can't bother to go and like write it again. So read var val in // riscos hyphen star / c star. There we go. In evaluate expression, we've, oh, that's the implementation. No, it can't be the implementation. That must be actual core to it, mustn't it? Let's have a look. Sublet / riscos evaluate expression. I think it's very, very lazy implementation of evaluate expression in there. So we just have a look at that. In C variables. Yeah, that's all it does. Just does a read var val, and there's a set var val version as well. Yeah, so we just grab that. Relies on the Swix implementation, retain register. Yeah, there we go, it's fine. Cool, not a problem. Let's go and dump that into here. Because all of these we can actually turn into calls to oslib or something similar when we need to. We don't need to do it right now because these are just going to be fine, but we can do that in the future. Whilst I remember, we also want to grab the header for that as well in not os. In, oh look, there's all read and write calls. Variables. In fact, we'll probably pinch those, can't we? Read var val. Yeah, we're going to need these variables as well, and we need those. Yep. So we'll pinch all of them, and we're going to put them into this header just here. Cool. I mean, again, we can replace this all with oslib at some point, but at the moment I'm trying to make them all these implementations nice and isolated so that they can be lifted and dropped elsewhere. The reason being that then they are so self-contained that you can use them without having the rest of the operating system, headers, build environment and everything all set up. The main thing we've got here is basically the C compiler, the main header, standard library, and a few other bits and pieces. So Swix is obviously in the standard library. I think that's pretty much it. There's also callx, which I consider part of the standard library as well, since you need it for modules. But yeah, that's what I'm trying to do here. So here's the implementation. So if we go back into main, we can actually call this to get the variable value. So what's we going to do here? We're going to have prompt var. Oh, I didn't define that. Prompt var to be CLI.prompt. Prompt. There we go. What I want to do is just go kernel error. Ooh, really not writing this very well. Os read var val variable prompt bar buffer we can write into. We know it's safe to write into the CLI buffer there, and we know that the buffer length is going to be long enough that it won't matter. Context. Do we have a context value for context? Should be 0 for the first call. Should be a constant for that, really, shouldn't it? Yeah, we'll do it for now. Let's do 0 for that. The type, we want it to be come out as a literal string. Oh no, we want to read it as a string, sorry, not a literal string. So bar type string. Context pointer, we don't want to care about that. We don't care about the oh, we do care about the length, don't we? Because it's not going to be 0 terminated. Is that right? Yeah, it doesn't get 0 terminated, so we do need to know the size of it. Where am I? Yeah. So no context there, but we do need to know the size, and we do need to know. We don't need to know its type. We don't care what type it is. So int size here. There we go. And there we are. So, and we can have the const char star prompt. If we got an error, well, we can go and print that out. Error this but in any case, we're going to turn all the printfs off eventually. We're going to have the prompt is in the global CLI buffer, and we also need to terminate it. So we need to do prompt bracket global bracket size equals a null character there. If we didn't get an error, oh no, that's the wrong way around, isn't it? Sorry, that's the success case. This is the failure case. If we get a failure, we want to do the prompt default. And that should be, I guess we should have it just as being a plain star, I suppose. Yeah, we can do that. That's cool. And then we write out that prompt. Should we start changing over to using the os-write calls, so we're actually getting these coming out cleanly? It's probably a good idea, isn't it? Yeah, we probably should be doing that. Let's make them get output as os-write calls. So os-write 0 prompt. Ooh, actually, oh no. This is, we could do this better. We could do this better. Prompt. Sorry. Size equals strlen prompt. And size has already been set there, so we can change it to be write n, which is the right way of doing it, because the prompt might have some control codes in it, like set the graphics color, so set the text color to be blue, which might be color 0, for example. It won't normally be, but that would make it a bit easier to use. So there we go. We do prompts there with that. There we are. That's quite cool. Right, but we also need to then start providing these os-write n calls. So I can pinch those from, not there. There they are. These ones here. So we've got, yeah, we'll pinch all of them, because then we've got the ability to write them all out. I want to put that into the header. There we go. There we go. All of the write calls are now in there. And this is just using a switch to use in this RISC-64 environment. there's this extra header that has extra more efficient implementations. Not that it really matters, but we can do that. And in future, we can make them even more efficient in the future. So that's going in there. I also need to get the implementations, which are in here. Spin to the end. Come on, all the way to the new lines. Yeah, there we go. So where's this going? It's going in OS. That's right. It's at the end of the OS. Here we go. So now we've got that coming out. We can also go back to here. So there's our prompt, command prompt being written. Command prompt there, read line, read line. We're using OSLI at the moment, fair enough. I actually want there to be, if there's an error, we want to print it out using a different sequence. That's os write n, write 0. What does it actually do in Pyro? Is reminders GOS error foo error colon. Right, okay, so that's good. I think that's actually looked up in the messages file normally, but we can do that relatively easily here in the future rather. Also write 0 of the to mess, because we know that that's 0 terminated. And then we want to write out the string for the error number. Let's go and just cut to there. Error number. And then we want to write out a hex error number. And we had a function that did that in debugger, didn't we? When we look back in debugger, that's here. We have a look in the veneer code, which is where we were before. Come into debug. Yeah, we've got a write hex 4. 4? Shouldn't that be 8? I feel that should be 8. Although actually, write hex, is that implemented in here or is it in OS? Oh, is it in OS here? No. Oh, where is it, do you think? It's not in there. IO? Ah, IO. Look, here we go. This is the fun thing. We've got, oh my gosh, look at that. That's a fun routine. Yeah, okay. Do I want to pinch those? I might just write a quick hex writer in here just for the fun of it, because I don't really need to do that. Os write hex. So what I could do is call the convert hex, but that's a very heavy-handed way of doing it. It really is quite heavy-handed, just calling into a system call just to do that. uint 32t IO you nothing. Right, nothing at all. Right, so how do we do this? I remember rightly, do char buffer, could be 9 characters, char star p equals buffer. Yeah. I'm trying to decide what the best way to do this efficiently. So what I want to do obviously is do star p++ equals hex bracket. Oh, hex char bracket hex and 15, and then we make like that. That's really all we're wanting to do. So 28, sorry, not 24. But v equals if p is not equal to buffer and v not equal, or v is not equal to naught. Get rid of that. And then we'll just do hash define. Yeah, this is probably way overthinking it, isn't it? Shift in there. Four, 20, 16, 12, 8, 4, 0. Have I missed anything? Yep, that looked good to me. And then finally, if p is buffer, I'll be the value 0 at the end of it. Rp plus, and then we can just write out, call os right n of buffer comma p minus buffer. There we go. That is how you write out a zero suppressed hex string. I mean, I'm not sure it's the best way of doing it, but that will work. And the point of this was to put the hex value here. Os right hex of the error number. And then finally, we do a close bracket and an os new line. Like that. Shall we see if that works? It's so very tacky. I mean, I'm not not proud of it, but also kind of proud of it. Where's my command to run this? Pyro. That one there. I also want to put the build in there as well. Oh, I should probably have put an and in that, shouldn't I? Because look, that hasn't worked. Build it. Lots of problems. Right. Lacks prototype. Oh, I haven't got included studint. There we go. Try it now. Wrong number of parameters. Ooh. I guess I missed one. And I've not invented strlen. So let's just insert strlen to begin with, because we can do string in here. Include string string.h. The other thing you might notice about this is that aside from like us actually calling some swis in here, most of this could be just run on any system. It doesn't need to actually be RISC-OS. We could have implemented the os-write-n calls as write functions, fwrite, just stood out, and we could have still had a kernel loss error, but just faked its values. And then we could have tested it on another system without having to mess around with RISC-OS. But it's better to actually try running it in RISC-OS anyway. Right, wrong number of parameters was my bug. So what have we got here? Have I missed a null off the end of it? I think I might have done. Yeah, I think there's a null missing there. So we have a look. We've got var, buffer, buffer length, context, type, context pointer, size. Yeah, I missed the type pointer. Should be a null at the end of it. One of the nice things about the newer compiler is it does tell you which parameter was wrong or what it was expecting, which is quite nice. Right, let's go build that, but I haven't put those changes in yet. That's just too much work for me. No, I don't want to save that window. I just want to run it. All built. And there we are. Star dot prints out the command. What was the other bit? Oh yes, so the whole point of this was CLI $prompt should be hello. Whoa, look at that. And if we were to do set Eve, is that how you do it? I can't remember. Oh, I think you just do it as a set, can't you? Set. So if I was to do set 17, 0, that's black. 17, 128 plus 15 is something and 3, 143. So that should be white background, black foreground. Right, which isn't working because we haven't told it to use ANSI. So I want to use ANSI VT commands to go and change the colors. Did that work? Oh, because I need to call the set again. Is that not how you do it? Anybody remember the VDU code for VDU? Is it VDU 17? Have I got the wrong one? No match. Okay, just VDU then. VDU drivers, please. Yeah. Okay, you've opened it in this. Give me a second, I'll go and dump it over here. We got a code in there. 1917 can use the text color. Huh. And changing the background color should be 128 plus 15, 143. I thought that should do the job. Go on. All right, so let's change it from doing that to doing... Maybe we're not in the right mode. Maybe we're in a 256, but it still didn't change the colors. If I change it to color 1, it should go red. That's not red, that looks a little bit different. So let's just try 19. Nope, that isn't doing anything. All right, echo 20, 27. So change to mode 27. Oh, that's not how you do change mode. Is it 22 to change mode? That might be it. But still, my colors aren't coming out right. Basic. Color 1. I'm still not getting... Is ANSI not how you use this? Do I have a help thing in this? I don't think I do. No, I don't. Ooh, that's not what I wanted. I didn't want to exit it. Doing well, aren't we? Kill that. Go here. Right, here we are. Right, so if that's not how you do it, the ANSI text. It is. I don't know how to use my own tooling apparently. There we go. So now I've got white on black and it's working properly, which is good. It's kind of pretty really. I mean, the fact that you can actually change the colour. So what you could do there is you could do that and then do 17 128, oops, 128, 17 1 there, like that. And so what will happen then is that that's not what I expected. I expected make this inverted, so that's inverted, and then turn this back to being, oh, no, 120 black background and a red foreground. But this part, the hello part here, should come out blue. Why is that not working? Why is that weird? Am I being dumb here? I don't know what's wrong there. I think that's a little bit, that's confused me. That has most definitely confused, no, that's confused me. Basic. Video 17,143, 17,0, colon print. Hello. Alright. Colon video 17,128, 17,1 print. Boom. Okay. Now don't output the next fly on there. What? Why are they different? Why are they different? I'm accepting any answers from people. Okay, quit that. Star Pyromaniac. Debug. Do we have work? No, we don't. I don't know what we actually have. Let's have a see. So video system. Video system will be down here, won't it? Video ANSI text has video colors output. Video output. Let's see what we can do there. Everybody else is probably in a food coma. That's quite possible, yes. Let's do video output and see what it's trying to do. There we go. Yellow, and then colors. See, look at this. This is interesting. Set text color 15, background's true. Then we go and do set text color 0. So it actually is changing the colors, and then it's writing out the output. It's weird, isn't it? I wonder if that's there's almost certainly a factor of something about Pyromaniac that's coming out a little bit odd here. And I'm not sure why. Yeah, I'm not sure why at all. That's very, very strange. Because that hello has come out okay. And then, do we print it out twice or something? Nah. Nah, I'm confused at that one. Oh, I think there's definitely something odd going on there. What I'm going to do is I'm going to set that aside because that's not related to this. It's probably just something in Pyro that's a bit weird. In fact, what we can do is we can prove that it's not this code. It's my Pyromaniac by trying to run it inside RPCMU. So here's RPCMU, and what we can do is we can jump out of this and we copy AAF32/GOS to be /library application support RPCMU hostfs. Oh, sorry, not GOS. It's called GOS FF8, isn't it? There we go. And then if we just drop into here, so we can see, yeah, there we go. Control, let's clear the screen, please. Probably want to make sure we're in 16 color mode, echo 2227. Right. So the command we were looking at, which is in here, we can just pull it up. Not that one. That one. Hello. I did reply to the issue I had. It seems only related to Select 409. All this is going to play. That's fine. Yeah, there's some. I saw your thing. I haven't seen what's up with it. Yeah, I see the notes that turn up there. I don't know what's going on, but I haven't come back to it. It's probably we've got some corruption somewhere or something that's a little bit unexpected, but I don't know why it would be going wrong. I will have a look back later. It's entirely possible that their WIMP is not supporting things in the same way that Select does, which, given they try and support all the operating systems, is, yeah, odd. But anyway, that's something we'll look at another time. So I'd prompt to be 17.143 17.0 hello star 17.128 17.1 boo star. There we go. That 17.143 didn't work. It's really weird. I thought that would work. It looks like it hasn't changed the background color. Basic color 143. Mode 27. Are we really in mode 27? 143. Oh, background color not 143. Add 7 instead. So that would be 128 plus 7 is 135. Oh, not 35. 135. Oh, 135 works. Oh, okay. That's interesting. I have to type the blooming thing in again now. Oh dear. Color 128, please. That's better. I'll type it again. Star set. Oh, see, it does come up in there. So yeah, it's something about Pyro that's gone a bit funny. I will need to have a look at it, but I'm not sure right now what it is. Kind of fun. Yeah, kind of fun. I wonder if it's to do with flushing. It's probably to do with flushing, isn't it? Pyro dev help config VD. That wasn't good. Let's say list config. Help config is very verbose. VDU. So there's a thing about flushing in here. Flush by position. Maybe I should have used help. Yeah. Right. Flushing. Yeah. So line position and char. So controls when the cursor output is flushed. All output is flushed when on classic. but most Unix tools don't do that. They usually buffer output when they run in a pipe. Position will flush the output at the end of the line or when the cursor is explicitly moved. Position should also include color changes as well. So if I do char, I'll bet it works. Config VDU dot flush equals char. And then set the prompt to that. No, it still doesn't work. Wow. Okay, well, I'm not going to worry about that. Do you have a full library of commands when you do a help search? How do you mean? So all of most of the stuff, what I just did. Oh, so that's help on Pyromaniac. So all of the things that I've written have lots and lots of help. Help on VDU. So that's the VDU help for RISC-OS Pyromaniac. All of the settings in Pyromaniac have lots of help on them to show you what's going on. That's what I was meaning there. Because the flushing is very different. All of the implementation is different, and a lot of it is configurable on Pyromaniac. So you can do huge amounts of control about how RISC-OS Pyromaniac works. So if you go to pyromaniac.riscos.online, there are. So if you've ever wanted to like just know a little bit change a little bit about how RISC-OS functions, you can change many of the things. If you have a look in configuration options, there's different different groups of configurations here about how things function, and you can change their behavior so they do different things. The bits I'm doing here on VDU, so we just go to the VDU here. You can see you can change the default alphabet. So in Pyromaniac, the host system is running 64-bit, not 64-bit, sorry, Unicode, UTF-8, but RISC-OS runs in Latin 1. So anything like a pound sign will come through as a UTF-8 code and things like that. There's also, you've got different implementations, so you can change it to use anti-text, which means you come out in color. There's also a bunch of others. So I'm trying to think of a good example in here because there's a lot. I don't know if you know OS GBPB. So GBPB, get byte, put byte, is an interface that allows you to read files in a directory. So you can enumerate the files in a directory. And the standard file core implementation returns you the index each time. But that's not defined. That's not the actual interface is not to return them like that. So if we go to file system here, you can change the behavior. So there's a number of things I can reconfigure whether doing close naught actually closes all files. Enumerate context, by default it uses identity, which is the next offset in the directory, but also you can tell it to exclusively order value. Reverse it, so all the bits are back to front. You can make the value go down instead of up. You can use a multiplier. All of these ways of doing it means that we can make the system's behavior a little bit different to try and cause things to break, basically, to break in an odd way. There's also an interesting thing here. So enumerate corrupts buffer. So what it does is the buffer that you've supplied isn't defined to actually be unwritten to it. It can do anything it likes to it. So the idea is if you've written to the whole buffer that was given and then something will go wrong, you'll see that your code is not working properly. There's other things as well, like we can change the file types to force things to be only in 0 to 11, so you actually get only 0 to 1000 hex as your, or FFF as your file type numbers, but could handle more numbers, so you can turn it on and off. there's other things as well in here, but you can change the whole way that the system works, largely to go and promote better testing and trying things out in different ways. Yeah, that's how Pyro works anyway. Everything you might want to do is very, very extensive. There's also stupid things like I'm trying to think of what other silly things we've got in here. Maybe not silly, but error handling. So you can get if you get invalid memory being returned, it can be replaced with an error message, or you can get it just returning back an error to the error pointer badly. And you can have the offler message turn up, or you can have different other handlings for that. So lots of different ways of handling it, and that's the way that I test things to make sure that in RISC-GOS Classic, it'll do what it's expected to do according to good practices. Anyway, that's what's going on there. Wasn't helping me in this, and I'm not going to worry about it, I think, because I don't know why it's broken. I'm going to have to look into it. It's probably something stupid I've done. JPEG workspace, why is it restricted to 5 megabytes? Which JPEG workspace? The one used by Sprite Extend? Or the one used by Compress JPEG? I mean, any memory area can be any size. It's just down to how it's been configured. In the task manager, I don't know what that is. Let me fire up RPCMU. I'll have a look at that under dynamic areas. I mean, I'm assuming that JPEG workspace is generated by, so it shouldn't exist by default. Yeah, you don't have any JPEG workspace by default. It'll only be used when you create a JPEG. So if we can find some JPEGs. Have I got a JPEG here? Oh, where the heck would I have put a JPEG? Am I going to have to like copy one in? Let me copy one in. I must have a JPEG somewhere in here. Live. Well, RISC-GOS 5 may be different, so I don't know about RISC-GOS 5 what they're doing in there, because I mean I did a huge amount of different things in how I've done things. So I look in talk site, Pyromaniac. Oh, sure, no, yeah, Pyromaniac. There we go. Graphics, Pyro 1 graphics diagrams. That's not got any. I know what I'll do. I'll look for. Find in there name star.jpg. Oh, you're kidding me. All right, anywhere, find me a JPEG. I don't have very many JPEGs apparently. Well, every dynamic area has some restrictions. That's just the way that they're set because you're allocating from logical address space. I'm being rather concerned that I don't have any JPEGs in here. This is very, very strange. An alien. All right, we'll copy that. I don't know what it is, but let's go and copy that into our things. So into / library application support RPCMU host of S, that's what I'm thinking of. And we want to copy this as alien1, C85 is the type for JPEGs, I think. Refresh that window. Alien. I haven't got anything to load it. If I remember rightly, we can drop it onto here and then do make background scaled. There we go. Oh, that looks ugly. Yeah, no JPEG workspace in there, I'm afraid. So I don't know what that one is doing. JPEG workspace in / Pyromaniac mod ROM modules resources ROM resources. Okay. Oh, cursively. Yes, a Sprite Extend apparently has it. So let's find Sprite Extend. Always happy to answer questions. Risk, oh no, I want, let me, gitlab.riscos open, not desktop, it's video render sprue extend, because as we know, we always remember every single path to all the modules, and we're looking for the, not the message file, we're looking at the source code, the S files. No S files, interesting. No S files is interesting. Is it all in C here? No, this is the S code, isn't it? Oh, so ugly, so ugly. Right, what I actually want to look for is din name, because that's where the dynamic area will be created. Din name is here, but that's the, what? Oh, that is so ugly. They're using a nasty way of looking up an error block to get the translated name. That is so awful. But this is the bit we want here. Come on, can you take me to it? All right, do I have to click on the line number then? Click on the line number, okay. Right, so here's the create the dynamic area. Not draggable, that's why you can't resize it. Maximum size is 32K is whatever size that is. Maximum size for 8K by 8K of GOS. Yep, that's fair enough. That's quite a lot. Python OX, whatever 1024. So that's 1 gigabyte is the maximum size, and this size here is, oh, that's OX, sorry. There you go, 5 megabytes as your thing. But again, that's using, that's the band buffers that are used for the system. That's, it shouldn't hurt you, it shouldn't do any different, but yeah, you can't resize it, allegedly. Higher. This has pointed to the variable with the current size, which is interesting. But yeah, so that's almost certainly what it's doing there. Oh, CS for higher than or same. I presume this is because we've got different areas going through the same function here. Just, yeah, ugly. And it's creating the areas. I'm assuming that's what it is. Have a chat to Viscos Open about what they've done there. I don't know what's that is. It's entirely possible the same thing is done in the Viscos Select version. Modules. Nope, nope, nope. Video render, not sprite util. Sprite extend. And what are we looking in? This is in put scaled. Yeah, I think the put scaled code was quite different. So we're looking here, input scaled. All the hard-coded code here for these things, quite cute. Put scaled I wanted, not that. Where's put scaled asm? Here we are. And this function was, sorry, I've forgotten already. Area resize. Area. No, it's not in there. So this is clearly a quite different way of doing it. Yeah, quite different. Let's scaled. This is all very different, actually. Yeah, not sure why that is. Not going to worry. That goes through the JPEG fetch routine. That's the JPEG handling. Surely it should be in here. I don't know. Let's have a quick look for area resize or din area. That's probably a better idea, isn't it? It's in sprue extend. So I'm assuming that they've they've reworked parts of this code, so it's got din area. Sorry. Oh, that's only there. Curious, said Pooh. Let's have a look for OS dynamic area. Swise and put scaled asm. So put scaled asm is probably the one. OS dynamic area. Yeah, this is looking more like it. Create dynamic area. So here, allowing it to be shrinkable. Hang on, they did it not shrinkable, didn't they? I've lost it. I've lost the code already. Area resize. There's the area resize. So they marked it as not draggable, whereas we've got user faulting. Yeah, fair enough, and shrinkable because it can be automatically resized down if we run out of memory, and we set the maximum to be 6 megabytes, with the 0 as being the initial size. -1 is the initial size. 5 is the maximum. Yeah. So yeah, it's slightly different implementation. There's the din name. Sorry, that's what I should have been looking for. And then we put handler on it. Ah, yes, of course they won't. They haven't got a handler on there, so they can't make it shrinkable. In select it's dynamic, which extends when it needs to, yeah. And it'll shrink back when it doesn't need to as well. It ought to anyway. If you're running out of memory, it's a shrinkable one that goes and reduces. So we do test shrink, and we handle post shrink, and we grow if we can, and we shrink, and that flushes the area out. Yeah, so they've obviously got a quite different implementation in there. And the reason for allowing it to be bigger and so on is that we want to be able to allow for much larger space to be handled when you need it, but when you don't, it'll automatically shrink down and people can reduce it. I mean, presumably that's holding the workspace it's using constantly, and you can't do anything to affect it, which really isn't a very nice user experience. Anyway, long digression there. It's 3:30. I haven't done very much, have we? Okay, let's see where we're up to. Right, so we've got handling for this great stuff here and some environment handler here. Okay, so what we're going to do is we're going to start at, have we got things actually committed? What have we got left changed at the moment? Oh yeah, we've added the command prompt. Oh, so we've got a command, we've got something done. We have done something. Yeah, cool. That's not bad. Let's add that in. Added command prompt and nicer error write out. Command prompt reads from the variable and writes out errors, and we write out errors with the hex number using OS write calls, not printf. In fact, we probably should replace all the printfs with dprintf, so we get them only when we're debugging. So let's add that code in as well. Let's put it up here. Hash define debug. We want debug on. Debug. And then we can turn that off when we're actually building it into a module, and we won't get any printf code called. That's good. Now we just need to replace the printfs we've got. Ooh, write command prompt. Yeah, we can do that. If there was an error, switch to the default. Red line Oh, aren't we also meant to write out a supervisor command line at the beginning as well? Pyrodev GOS. Yes, we are. Okay. So it is error colon. Error suffix is bracket error number ampersand, and then the trailer is just a bracket. And what we can also do here, I think these actually end up in tokens, but again, internationalization can come later. We don't care about that. Yeah, so we'll just go and fix that so that the errors use those values. So we've got error prefix here. These may not even be needed. We may actually replace these in the future. Error suffix and then error trailer. And you can go away. Yeah, half an hour, because we'll be done then. So that's those ones done, and we want to now also include the supervisor title. Really, supervisor is not a good name, but yeah. And we could just as easily say welcome to Riscos or something. Before we start doing any of that, yeah, we need to do it here, don't we? So we want to do os write 0 of supervisor title, and then os new line. Okay, and read line. Okay, so we'll just make those. Those have now become defined, so we can. I'll just commit that and send it up. Commit -a. Make the output strings find There we go. And push. Bum, bum, bum. Okay, so what we want to do now is we want to mark out where we want to set up the environment. So what we want here is env this is the wrapper environment, isn't it? We're going to have different. Oh, I know what I'll do. I'll look in Pyromaniac, because in Pyromaniac we've got an implementation of this. So Riscos utility module. There we go. So we have a look at this, and we should see down here. So you've got lots of bits, some prompt handlers, escape handlers, various entry points in here, and deleting the utility module is foolish. Yes. Default handler setup here. Now, changing our handlers. This is the environment handlers we're talking about. Here's where we write out supervisor. Oh, we actually write out 2/n's. All right, we'll fix that up. We then we do a magic thing that goes and exits us back to user mode to make this happen. Run the prompt. Escape check. Yes, we want to check whether people have pressed escape in between things. That's a good point. There's the prompt printing. reading the CLI buffer size. Oh, reallocate our buffer only if the buffer size changes. How badly would the system be if the CLI buffer could change in size between different invocations of the command line? That is what that's trying to trap. Yeah, scary, huh? So we've got default handlers and we've got our handlers, and that's how we've done it. And then in here, just before we invoke it, no, we don't actually have different handlers for this, but I think we're going to for this code. Default handlers and then call us exit. Right, okay. So this isn't that different, and I didn't give a particular name to it. Oh, we need to acknowledge the escape as well. Maybe I should. Oh, we just write out an escape there like that. Interesting. Yeah, fair enough. I'll come back to that. That's not a problem. What I'm going to do now is go and put in some stubs for setting up the handlers. Don't have upcall handler in here. That's a mistake, isn't it? We should definitely have an upcall handler in there. Yeah, we'll have to do that later. Right, okay. So if I'm going to do it this way, we're going to have GOS handlers. Env GOS start. Should I put start? Apply. Apply and restore. Yeah, so GOS apply. So we set up the GOS handlers there. Global. And then at the very end, we go and restore them. Restore the error handlers for the parent system. There we go. So that's restore. Okay. And then we'll also put that in there. We'll implement those later. And then in here, we have a slightly different set of handlers because we want to check whether the input string was a star. That's that one there. Set the environment for what crashes. That's the one around this. So we do env CLI apply there, the global ones, and then env CLI restore. Oh, should I put it after the comment, shouldn't I? There we go. Invoke CLI line input, and that should go before that. Right, so we've now got 4 functions that need to set up the environment. Let's do them. So we've got void env CLI, GOS is it apply, and that takes a global workspace T global, and we've got one for restore, and we've got the same thing for the CLI. Okay. Not doing great yet. There we go. And then for each of these, we'll just print out a message. Just for now. Env apply GOS environment. Restore parent environment. And this should be apply CLI environment, and then here restore GOS environment. Okay. So this will need to handle all environment handlers should be set mostly to the defaults. All environment handlers should be preserved. Okay. I've definitely done something with environment handlers of late, and I can't remember what it was. I'm sure I've done something with these. I can copy the code if I've got it. So this one, all environment handlers should be restored from the parent. And this one, CLI apply. All environment handlers should be set. No. Environment handler for errors, exit, and crashes should be set. Restore the GOS environment. Okay. So it feels like this particular function, the restore the GOS environment, is very similar to this one, except that this doesn't preserve them. End GOS apply global comma false. Don't preserve the environments. So this will basically put things back after the command has exited if it left anything in a bad state. Because there shouldn't be anything wrong with that. All right, and so that's going to mean that we need to pass in a true here because we do want to preserve it there. And most of this is just setting up the default handlers. So we want to remember all the environment parameters. Now, all the environment parameters have different values in them. So we're going to define a struct for an environment handler. Where was I working with this recently? Come on. Was it in... Recently, it could be in the last year or two, so not very helpful. GOS environment. I'm pretty sure this would have been in the C library. So riscos simple binaries. There we go. Because the 64-bit environment will have had to do something like this in the C library. It's quite a big directory that about me. Can I just search in clib, please? No. Oh, because it's not called OS environment, it's OS change environment. Oh. Interesting. So in swise.s we've got something there. Oh, let's just open the whole blooming directory and have a see. Subler. Right, so in swise.s down here, we've got an OS change environment, which makes sense. And the function is just called OS change environment. So if I look for that, but in lowercase, why it didn't find anything. Ah, environment in the environment file. That makes perfect sense. Have a look in environment. Here we go. Here's all our handlers. Oh, look at that. Old handlers. Oh, we need an error buffer as well, don't we? Yeah, that's true. Okay, so this is all pretty good, isn't it? We can just pinch all of this. Here's the escape handler for the C library. Yeah, see, this is all very, very similar. Cool. All right, but basically I want to copy this lot. That's quite nice, actually, because I can then just embed an entire handlers block into here. So we go, don't do it that way. That way, that's the handlers. Cool. We're also going to need, oh, hang on, let me move my window up so you can actually see what I'm doing. That's the exit handler. init handler. Here we are. This is doing the initialization that sets up all of our handlers and the ones that go to other places. That's storing them. That's quite nice, isn't it? Oh, look at that. And this is the restore one, which is very similar to what we're doing there. Maybe this should all go in. This is all in one file, isn't it? Maybe this should all. This is very, very similar code to what I want. Not quite, but very similar. I'm going to pinch this and I'm going to put it into an env file, I think. I think that's the right thing to do because we can actually have the environment managed in a different way then. So env there. Yeah. We'll have this in here. Env program environment handling. So some of this is going to be like exactly the same. So this is env init. This is initializing them. This is actually env GOS apply. So in this case, we're not actually writing them into anything. So what we've got is our global pointer, workspace, and we've got another parameter here, which is preserve equals true if we are preserving parent and false otherwise. And false to just assert. Env GOS apply. Global oh, this is interesting. We're going to end up with some recursive things in here, aren't we? Some definitions that are a little bit awkward. That's fine. This is global, and each of these, where we've got old handlers, that should be slightly different. We should replace that. So copy. Old handlers. We want to do that to be ampersand global to, this is the parent handlers, just like that, yeah. And this actually only wants to be the case, so if preserve, not preserve, null. Otherwise, parent handlers. Okay. So what we should end up with there is, yeah, that looks good. So some of these we've actually got functions in here which aren't going to work. So we're going to have to do something fun with those. For now, what I'm going to do is, I can't do that. It's frustrating, isn't it? Yes, because we can't actually assert the environment when we're inside the regular C application environment. We can only do that when we're in a module. So we're going to want to have something a little bit different about that. Maybe we'll make the function do a different thing. But shall I pinch the old? I could pinch those. No. We do need an error buffer though, so this kernel error buffer needs to be something we've actually got as a value. So we need global to error buffer. There. Env error. Let's just define env error. We'll pinch this and make it crash. Actually, making it crash might not help. No, make it crash. What the heck? There we go, crash. Because if we crash inside the error handler, it's quite possible that we'll then go and crash badly because we will recurse. Same goes for the exit handler here. Ooh, probably the escape handler too. So all this will have very, very bad effects if you actually try to call them. But at the very least, we should be able to do something with it. Oh, we've got these old handlers. Ah, right, okay, let's go and old handlers dot replace with global to parent handlers dot. There we go. That's good. And then we can go and pass in the globals here to pinch this top definition, since it's going to be near enough identical. We don't have a preserve thing though, and this is restore. And GOS restore. We're not actually marking it as initialized. That's literally just restoring all the handlers. Yep. So we need some includes in this. So we have a look in here. We'll see what the includes are. We're going to need all of those. Probably. We're going to need we're going to have to move all the global workspace into a global.h. It's going to be necessary. What else? Environment numbers. So the best place to include that from is to include, oops, riscos / env numbers, I think it is. And since we're not actually going to have this implemented, what we're going to do is we're going to define an os change environment env in1 in void star in1 void star in2 star in3 and void star star out1 and so on. I think that's right, isn't it? Oh no, there's only one output in this. Oh, because that's just, yeah, where it writes the whole lot to. So a lot of this is going to like break badly, I think, but we're just, because we're not actually going to call things, we're just going to like do some things here. Where do we go now? We're going to here. Yeah, so I need to copy all of this down to here into our global.h. New folder. Come on. Oh, you didn't. I didn't mean new folder, did I? I meant new file. Yeah. Am I deleting the right one? Come on. Really need to close some windows. I've got far too much open here and it's running a little slow because of it. I mean, you can't see this, but I've got like huge number of Sublime windows on another workspace that's got all of my current work on it. There we go. Come on, new file. global. That's what I should have done. Then I can paste into it. Thank you. Not that. Global workspace for the GOS handling. Include studint uint 64. That isn't very sensible. In fact, probably all of these should be 32s for the current environment. Let's go and replace them. Inputter T to be uint 32T. Okay, that's fine. I'm sure it'll not have any bad effects at all. Stored parent environment is parent handlers, which is a handlers T. Endif at the end. I also need, if I have a look in env, I want to create the env header as well, don't I? Env envh, here we go. RISC-OS error buffer type. That's right, I need that as well. That wasn't what I was looking for, but I will need that defining in here because we need to put an error buffer in here as well. Which is a RISC-OS error buffer. Our error handling. Yeah, it'll do. Yes, fine. Okay, that looks good. What I wanted though was to know, because there's env-read it was using in there. I'm presuming that we've defined that somewhere. Yeah, env-read, there we go. It's defined there. Let's go and put that into this one. Env-read, that should just become a uint 32. No, uint. Actually, have all the others got? No, I think they're okay. All right, that looks not terrible. Except I've written 23 rather than 32. That's not going to be used. We're going to get rid of that because we can't have. We might want to introduce that later, but for right now, I'm not going to need it. Env here, yeah, this needs to be this header. So let's go copy the entire file, put it here, get rid of the implementation, and if get rid of the implementation. Those ones won't be called from anywhere else. That's internal. And we get their numbers. Just need the global workspace, and then we're done. Okay, so then we can just go into here and do. Oops, I missed the N off that. Don't need the numbers there either. Okay, let's dump in env in here, and we also need to make sure we include env in here. Oh, and global as well. We need global. Okay. Very unlikely this will all work. Are you still running a 4-monitor setup? Yes, I am. So the coding you're seeing here, this is top left window. This one over here, top right window. Just below that, down here, which you can't see, just down here, is where I'm monitoring the chat, and I can see number of people who are watching it and that I'm streaming. and then down below, so this one here I go and drag to this, oh sorry, this one here, if I drag down from the top left window, that's where I'd put things that I'm keeping out of the way so that we can actually see the screen. So I can pull them back up again, and then on the monitor, the laptop itself, I've got the OBS that's actually the thing that's recording and streaming to YouTube. It's fun, and you can understand why at the beginning I got fun bits where I did stupid, not worky things. Serious legal left operand. What? Why is that? Global to parent handlers. Dot memory limit. Isn't that right? Alright, so we haven't got stud-int. Let's get stud-int. Studio, sorry. There we go. That's the printf thing fixed. Global workspace. Expected a bracket. It doesn't know global workspace T, so why is... I've included global. Global workspace T. Handlers. Oh, this isn't valid, that's why. What? Serious error. Oh, kernel error. Oh, right, okay, so I need to include kernel.h, so it invalidated that entire file. Okay, save, build. So Viscos UK is using two 34-inch widescreens. I find that widescreens are okay if you've got one, maybe two of them, but I like having the vertical space so I can actually work with windows vertically. Again, you can't see it, but the two lower screens are vertical. They're 4:3 as well, which means that I can see whole documents and work on those. And because they're lower, they're the ones I'm using more often for actual coding. I look down a little bit on those, and the ones that I'm coding rarely are on the higher ones up here. So I just have to use the higher ones for it because I want to keep 4:3. I think if I was coding everything, if I was coding everything on a vertical screen, 4:3, people would probably curse me on YouTube. It's bad enough I'm using 4:3, and most people are probably using widescreen anyway. So that's sort of the why. Right, what we got in here? We've got undeclared preserve. Oh, because preserve isn't used here. Oh, yes, it is. Oh, I copied it. Oh, that's why. Bool preserve. I went and overwrote it when I copied the definitions. So Talia has two widescreens, left and right downstairs, but she tends to work on one of them and has the other ones as a reference. So she has a different way of working, which is really cool because you work the way you want to. Cast a pointer to non-equal pointer. Void star star. Maybe I should just make that a star instead. Still doesn't like it. Cast between function pointer and non-function object. Line 79. So remind me what these are meant. Is it? Hang on. I had definitions for these, didn't I? No, not that. Not in there, in global. Yeah, so these should be UNTs. I should define them as the same types as we've got in here. So yeah, go back to here. That should be one of them. And if the camera was working, so the camera actually sits, so you can see where my pointer is, it sits just under here. So as I'm staring at the screen here, which is where it is, I'm looking at least vaguely towards the camera. If I'm presenting, I'm often looking up there, but I can at least look down towards the camera, so I can see where things are. It's a little bit weird having the the chat over here, so I actually have to look that way to see where things are, where people are talking. I mean, logically, I should really have that below here, so I'm actually looking closer to the an up-down look, but another time. Global error buffer wasn't defined. Where's that? Sorry, global error buffer. That one. Global to error buffer. Sorry, that should be that. That's why. Oh, we're getting better. Function implicit cast of pointer to int. Well, why is it working in here then? So look in the header. Oh, no, the swise, oh, okay. Swiseos.h, where's that? Swiseos.h. Change environment. Int pointer, okay, they're int pointers, that's why. Right, okay. You know what, I'm just going to go and cast them to what they're meant to be, what they're expecting here. Int32t, just for sheer ease. I should probably use an int pointer, but I don't want to break 64-bit stuff when I come to it. Although that's what the 64-bit stuff is using, so maybe it's not such a big deal. Aha, right, okay, so we go back into main. We should be able to delete these GOS apply because these aren't needed anymore because they're implemented in the other function. And we'll move the actually probably move those over there as well. I'll leave them here for now. But that should now be safe. Oh, except I haven't got the, I want to put the messages in there so we actually know what's going on. So what we'll do is we'll take this one, so it says restore parent environment in there. Oh, in fact, I might as well take a copy the comments as well. And this one, we'll do the same. Get rid of all this. Don't think we've got a dprintf in here, so we're going to have to quickly pinch that as well. Yeah, there we go. Copy the debug code. Yeah, so we're running over time again, as always. Sometimes I'm good, but not this time. But we'll just get this bit done and then we'll call it a day. Oh, wrong number of parameters to DOS apply. Oh, right. Yes, okay. This is not being caught in here because I've got those wrong way as well. That's a more global header than that one. Because I didn't include the header. So I just need to pinch this. Put it in here. Build. Okay, there we go. So now if we try running it, pyro dev. Yeah, flush char doesn't seem to do anything. I need to find out what's wrong with that. It's very weird. Something is definitely strange with it. I don't know why, but we'll look into it. Right, that would have changed the environment, and then when we type echo, it goes and applies the CLI environment, restores the GOS environment. Ooh, reapplies GOS environment. Is that right? Maybe we should only be doing the apply GOS environment at once at the beginning, because otherwise we're storing it. So if I do quit here, yeah, we would have gone back to the wrong thing. GOS apply. Oh no, the GOS apply there is the one that's being called on behalf of apply restore GOS environments. So actually, yeah, that's safe. That's safe. Okay. Git status, because we've got a whole bunch of new files, C and H. Commit minus A. Right. Add stub implementations of the environment assertion code. Environment setup and teardown is semi-implemented. It needs to be used in a real environment, not here, but is working as a diagnostic right now. Okay. So, yeah, overrun time on this. So, what have we done? We've managed to put together a basic command line processor. It's not actually an interpreter, it actually just processes around this loop so that it can go and handle setting up the environment, printing out messages, getting a prompt, reading a line, checking whether you pressed escape, checking if you're exiting, entering, doing a command, restoring the environment, and doing it repeatedly, and then finally restoring the environment. All of this is set up in such a way that, in theory, we can use the global variables through a structure, which means we can have multiple of these. And we will need to start putting together some bits that actually handle the environment in a proper way for a module. But it's all working right now as a simple, yeah, pretty simple command loop. Nothing too special, but it's set up so that it can work there. It's going to be a bit fiddly, however we do this, but we can make it happen. Probably be here next week. I'll post a thing up on GOS Open forums later to say what we're actually doing. But what I plan is to try and get a bit more done next week so that we actually start applying these environment handlers and we actually have callbacks to things. We can start putting it into the environment in a useful way. One of the advantages of doing it this way through GOS Pyromaniac is that when I get it wrong, and we will get it wrong, the normal way that it goes wrong is that it blows the system away. And you can't see anything because you're calling the environment handler for exit, which then crashes, which then calls the error handler, which then calls the exit handler, which then crashes. Or you call the error handler and the error handler crashes and you go around in a loop. So all of those things are difficult to handle. In Pyromaniac, we can actually stop it at any point and basically say, what's going on here? Print out diagnostics to see how things are working and so on. All of which will make it simpler for us to handle how things are broken. That's the plan anyway. So I can now start updating the status. I should probably do that now, shouldn't I? Let's do it now whilst we're here. /status. Oh, I've got more things called status now than I had before. Net status has been implemented. And then in here, we can update the status in here. So what we got? Utility module. There it is. We now have, how far have we got with it? We've probably got as far as it being a stub. I don't think we can really say it's much more than a stub, but we do have a stub implemented. And if we go into the features as well, feature utility module, prompts showing with a star. Yeah, that's good. I don't think we can say any of the others are done because they're not actually environment handlers. So we'll leave it as just one thing. Have we handled any services or anything? Nope, we've not done any of that. And we haven't got a star command because it's not in a module yet. So that's now done. Status commit -a. Updated status for the utility module. GOS. We've started it. There we go. And so the status will now show that is now started. Right. So yeah, the Viscos UK says any progress is good and a stub is progress. So I'm trying to make sure that I record all of the details about where we are as we progress through them, so that everybody who's following this stuff can see we are making progress, or that we're not. I mean, that's also a valid thing here. If we go, if this is the actual page here, if I reload this document now, we should see that it's now, we've got some ticks in there, woohoo! And we've got 10% of the functionality, because there's 10 blocks and we ticked one of them. We haven't done the 64-bit yet because we haven't check tested that that works. So we're getting a little way, and that means that people can start seeing a little bit more. Oh, look, we're at 76% now. That's quite good. I thought it was at 71. And the utility module is there. We're progressing something. All right, that is where we are. Next week we'll have a look at things some more. If anybody has any ideas for any particular sort of quick intros of I want to do this, how do you do it, we can go and talk on that, and I can do a video about it maybe. I've still got my plans, ones that I want to do. Assuming that nothing bad happens, I'm hoping I'll get those done. I may, however, find that I haven't got time because something else crops up. We'll see. All right. Have a good week. Have a good rest of Sunday. And I will see you next week for an Easter Sunday thing. Ooh, should I do something special for Easter Sunday? I can't think of anything that would be interesting to do. It might be that I end up thinking of something interesting to do for an Easter Sunday thing. Yeah, we'll see. Dress as a bunny. I am not dressing as a bunny. No, I'm not dressing as a bunny. I was just trying to think, can I go and get some ears or something? No, we're not doing that. I was just thinking, can I do a little picture that is some a bunny rabbit or something, and show people how you write a program that does a bunny rabbit. But that's really not that exciting, is it? I don't know. We'll probably just be continuing with this. Sorry, that'll be boring, I'm afraid, but that's life. All right. Have a good filter. Yep. If you can come up with something that is simple enough to describe and say this is what I want to do, then yeah, you can do that. All right. See you all later. Have a good week. Bye. Oh yes, like and subscribe and all that as well.